Good morning, everyone. Today, I would like to present our paper with the title Andalas Medical Robot Assistance Serve COVID-19 Isolation Patient. So, the outline of the presentation first is COVID-19 threat, second, AGPS delivery assistance, third is programming, fourth conclusion, and fifth is acknowledgement. Let's come up with the first uh, COVID-19 threat. COVID-19 is a pandemic disease. Coronavirus emerged in Wuhan, China at the end of 2019, and the disease spread rapidly over the world. In Indonesia, coronavirus appeared in early February 2020, and Indonesian government take a serious step by enacting or large-scale social restriction, call it as PSBB, in March 2020. Indonesian mortality also more prominent than the world mortality, which is 4.68% and 3.79% respectively, uh, per 3 August 2020. And 2nd September 2020, Indonesia has 180,000 confirmed cases and with 7,000 deaths and 130,000 received across 34 provinces. One of the most significant outbreak causes to blow up number is hospital cluster. The hospital cluster is one of the biggest causes of spread of COVID. More than 24,000 cases, which is 63% from the hospital outbreak. One of the reasons is the patient contact with the medical team. Daily checkup tasks are communication source between the patient and the medical team, such as food delivery, clothing delivery, temperature check, and etc. This is a serious risk that can be minimized by using a robot as delivery assistant. So AGV as delivery assistant. AGV is very common automatic guide vehicle in manufacturing as a transportation to move goods and stuff in you know, in factory. The user only need to assign a delivery task to AGV. AGV deliver good product material to design location. Most AGV system use the priority based single AGV order task method. So in our uh, robot AMIRA, there are three control system, which is the first is uh, control uh, the the AMIRA, the robot driven by joystick, which is connected with Raspberry Pi 4 through Wi-Fi connection. Raspberry Pi 4 send the data to Arduino Uno to control the navigation of AGV. And the second positioning system is using IR, which is to track person or obstacle through the receiver and transmitter. And whether there is object in around the range of 0.6 to 1 meter from AGV. The IR sensor will send the signal to Arduino transfer to the Raspberry. And the third auto uh, positioning system is using autopilot system, which is Wi-Fi module transmitter installed in the 10th point of, in the wall, which is 10 point, by using distance between the receiver and every transmitter. HCP, the location can be mapped effectively. So another features of AMIRA is temperature measurement, which is the temperature sensor measure for the patient. And the temperature will have medical team to check the temperature patient remotely. And the patient point overhead around 10 to 20 centimeters to the sensor, and this way the patient temperature will measure and display both in AMIRA LCD and nurse station LCD. So another features of AMIRA is anti-collision system, which is using IR sensor and vibration sensor. And IR sensor is reflect infrared from the object in front of the sensor. And for the vibration sensor placed around the bottom of AMIRA behind the collision path. The collision path will observe the vibration when the collision occurs. So another feature of AMIRA is hand-free disinfectant. There are two systems of free disinfectant here. It's actually hand uh, located in upper part left side and right side to prevent coronavirus contamination. And the second one is actually part for being a hand-free disinfectant. AMIRA is also equipped with room disinfectant spraying. And AMIRA also has feature of an emergency system. Sometimes AMIRA is needed to urgently, like emergency situation of the patient. When this happen, AMIRA needs to navigate and handle to satisfy this urgency. AMIRA is installed with an emergency siren and the siren equipped with rotating light resonance loud sound to alert people. And very the most essential features in AMIRA is schedule delivery. So for schedule delivery, AMIRA is equipped with the schedule dispatch program that allow navigate to move to the operator designed position. AMIRA will send a beverage to coronavirus patient so that the medical team direct contact with patient will be reduced. And camera attached to the AMIRA can scan QR code. This QR code is placed in the design schedule delivery area. AMIRA navigate to the patient room area and the robot scan the QR code that has been prepared attached to the door. And in this situation, the robot has already known the patient identity in the room and the robot alert the patient via a loudspeaker. So actually, for the programming of the AMIRA, we built the system using Eclipse IDE application in Java programming language and the communication system using uh, Python language. And controller, a microcontroller, sensor, and motor are controlled by C and C++ programming. The robot will calculate its position with this point by utilizing large signal strength. We call it as a receive signal strength indicator. And this signal is processed by support machine vector machine algorithm. When the robot is in front of the isolation room door, the camera on the robot will read the QR code and call patient according to the data built by uh, PHP and uh, MySQL database. And this is AMIRA in action, but still going on for the for designing the AMIRA until the end of this year. Conclusion: AMIRA's features can at least reduce direct contact between the medical team and COVID patient. AMIRA can play essential role in reducing the spread of the virus, and crucial to develop robots who are artificial intelligence to provide services to patients by offering hospital features such as robots that can communicate with patients, entertain patients, and therefore very involvement of various fields of science is required to achieve this. So this is the acknowledgement, and thank you very much for your attention.